Have you ever wondered if you could travel back in time to relive your favorite moments or leap forward to experience the future? This fascinating question has sparked the imagination of many, making time travel a captivating topic in science fiction and popular culture. It's a concept that has intrigued and puzzled scientists, philosophers, and dreamers alike. Whether it's a nostalgia-laced journey to the past or a curiosity-fueled leap to the future, time travel remains a tantalizing prospect. Well, today we're going to explore different theories of time travel that might just make you question everything you thought you knew. Time travel isn't just for science fiction. Some of the greatest minds in science have proposed theories that could make it possible. These theories don't involve a flux capacitor or a blue police box, but rather they are deeply rooted in the realms of physics and mathematics. They challenge our understanding of time and space, pushing the boundaries of what we thought possible. Imagine for a moment that you could jump into a machine, dial a date and time, and be transported to that moment. Sounds like a fantasy, right? But what if it's not? What if the laws of physics allow for such a possibility? From Einstein's theory of special relativity to the mind-bending concepts of wormholes and quantum mechanics, these theories are more than just conjectures. They are carefully thought-out possibilities that challenge our perceptions and could redefine our understanding of the universe. So, buckle up as we travel through time, exploring some of these fascinating theories. Let's start with Einstein's theory of special relativity. The cornerstone of this theory is the idea that the laws of physics are the same for all observers, regardless of their motion or lack thereof. But here's where it gets interesting. Einstein also posited that the speed of light in a vacuum is the same for all observers, no matter how they or the light source are moving. This theory introduces us to the concept of space-time, where space and time merge into a four-dimensional continuum. You can imagine it like a fabric upon which all objects exist. Now, the presence of mass or energy distorts this fabric, creating what we know as gravity. But how does this relate to time travel? Let's think about it this way. According to special relativity, if you were to move at the speed of light, something extraordinary would happen. Time would slow down for you relative to someone who is stationary. This is known as time dilation. The faster you move, the slower your clock ticks compared to someone at rest. So if you could travel at the speed of light, you'd be able to reach the future faster than those left behind. However, to the best of our current scientific knowledge, it's impossible for anything with mass to reach the speed of light. So in Einstein's universe, time travel might be possible, but there's a catch. You'd need to travel at the speed of light. Now let's dive into something even more mind-bending: wormholes and quantum mechanics. If you've ever seen a science fiction movie, you're probably at least a little familiar with the concept of wormholes. They're often depicted as swirling tunnels of light that allow characters to instantly travel vast distances across the universe. But what exactly is a wormhole? In the realm of theoretical physics, a wormhole is a hypothetical structure of space-time envisioned as a sort of tunnel connecting different points in the universe. Imagine a piece of paper representing space-time. If you were to fold the paper over and create a bridge or a tunnel between 2 points, you've just created a simplified model of a wormhole. The idea is that a wormhole could potentially provide a shortcut through space-time, allowing us to travel enormous distances in the blink of an eye. But the big question is, could it also allow for time travel? This is where quantum mechanics comes into play. Quantum mechanics, the branch of physics that deals with the smallest particles in the universe, has a peculiar feature known as quantum superposition. This principle allows for particles to exist in multiple states at once until observed. So how does this relate to time travel? Well, some interpretations of the quantum mechanics suggest that the same principle of superposition could apply to space-time itself. This means that the past, present, and future could all exist simultaneously. If we could somehow navigate this quantum superposition of time, we might be able to travel to any point in time, just like we travel to any point in space. However, it's important to note that these are purely theoretical concepts. While they provide exciting food for thought and make for great science fiction, we have yet to discover any empirical evidence to support the existence of wormholes or time travel through quantum mechanics. It's a wild ride, isn't it? Quantum mechanics and wormholes open up a whole new world of possibilities for time travel. But what about the paradoxes that time travel could cause? Ever heard of the grandfather paradox? Dive into the world of time travel and you're bound to encounter some mind-bending paradoxes. One such paradox that's been a hot topic of debate is the grandfather paradox. Essentially, it presents a logical conundrum that would seemingly make time travel impossible. So, what is the grandfather paradox? In a nutshell, it's a hypothetical situation where someone travels back in time and kills their own grandfather before the conception of their parent. This, in theory, would prevent the time traveler's existence. But if they never existed, how could they have traveled back in time to kill their grandfather in the first place? This paradox is a classic example of a loop with no start or end point, a causality loop in scientific terms. It's a riddle that confounds our understanding of cause and effect, the basic principles upon which we base our understanding of the universe. The grandfather paradox isn't just a fanciful thought experiment. It's a serious topic of debate among scientists and philosophers who use it to explore the limits and implications of theories about time travel. Some argue that such paradoxes demonstrate time travel to be impossible, as it would violate causality. Others suggest the existence of parallel universes or multiple timelines, where the effects of such paradoxes could be contained without causing logical contradictions. Quantum physics offers another perspective. In the quantum world, particles can exist in multiple states simultaneously, only settling into one state when observed. Could a time traveler then exist and not exist at the same time? Could they kill their grandfather and yet still be born in some strange quantum mechanical way? These are the kinds of questions that keep scientists awake at night. They push the boundaries of our understanding, challenging us to rethink our assumptions about time, space, and reality itself. The grandfather paradox certainly adds an interesting twist to the concept of time travel, doesn't it? As we've seen, time travel is a complex and fascinating topic that challenges our understanding of the universe. It's a concept that's been the subject of countless science fiction stories, but when we delve into the actual theories, we find that reality might be even stranger than fiction. We started with the theory of special relativity, a groundbreaking idea from Albert Einstein that introduced us to the concept of time dilation. This theory tells us that time can slow down or speed up depending on how fast you're moving relative to something else, opening up the possibility that time travel could be achievable at near light speeds. We then ventured into the realm of wormholes, these hypothetical shortcuts through space-time that could potentially allow us to hop from one point in the universe to another in an instant. These are not just figments of our imagination, but are solutions derived from Einstein's equations of general relativity. Our journey continued with quantum mechanics, a field that often seems to defy common sense. The many worlds interpretation suggests that every decision we make could spawn a new universe, a new timeline. Could this mean that time travel is simply a matter of moving between these parallel universes? And of course, we couldn't discuss time travel without addressing the grandfather paradox. This thought experiment asks what would happen if you traveled back in time and prevented your grandparents from meeting, thus preventing your own birth. It's a mind-bending conundrum that sparked many debates. These theories and paradoxes highlight the ongoing scientific debate about the possibility of time travel. Some scientists are skeptical, while others believe that we simply haven't discovered the right technology or understanding yet. What we can agree on is the fact that these theories push the boundaries of our knowledge and inspire us to keep exploring. So, while we may not be packing our bags for a time travel journey just yet, the theories we've explored today remind us that the universe is full of mysteries waiting to be discovered.